Today's lesson deals with the converse of the Pythagorean Theorem. Who remembers what the Pythagorean Theorem is? Yeah. Okay. Don't question about, are we using CAB? Yes, we are using CAB. We don't use ABCs anymore. ABCs, young kids. CAB is for us. We're starting to drive. Think about driving cars. CAB. We use CAB now. We use CAB because it is way more flexible, and today is the main reason why we use it. Whenever you have an equal sign, you have a right triangle. But what we're going to learn today is sometimes it's not going to be equals. Sometimes it'll be greater than, and sometimes it'll be less than. Whenever it's greater than, you have an obtuse triangle, and whenever it's less than, you have an acute triangle. This is why we use CAB. If you think of it, less than, that means small, so small goes right with the word, acute triangle. Greater than, that means big, so does the word obtuse. These go hand in hand. But if you start using ABC, a squared plus b squared equals c squared, you're going to get these wrong. You have to use CAB. You have to use CAB. So over here in the little theorem box, if they're equals, then what kind of a triangle do we have? We have a right triangle. So one more time, if that theorem is true, then we have a right triangle. Now we can look at example 1. On this example, we're given a few different terms. Since it gives us all three sides, we're not going to be solving for x this time. Instead, we're going to try to figure out what inequality symbol, or if it's a regular equal symbol. So, first off, it says, is it a right triangle? That means, is it equal or not? On this triangle, what piece is the most important? The hypotenuse. Which one's that? Okay. And I really don't want you to focus a whole lot on hypotenuse on this kind, because we don't truly have a right triangle, meaning we don't truly have a hypotenuse. Focus on which one's the longest. This one is the most important. That's your C term. So let's write that down. We have 3 square root of 13. And remember, we're squaring this whole term. We don't know if it's equal to, so I'm going to put a question mark over top of that. And then we have the other two legs, 6 squared and 9 squared. This right side is really easy to simplify. 6 squared is 36, 9 squared is 81. But a lot of you had trouble on this side on your homework. This is an Algebra 1 topic dealing with radicals and exponents. It's kind of like distributing, or another way to think of it is, what does it mean when you square a term? Multiply by itself. So this makes it easier in my opinion. If you multiply that by itself, well, what's 3 times 3? 9. And any time you have a radical times itself, you just get the number underneath. Anytime you have a radical times itself, you just get the number underneath. So that's pretty easy. 9 times 3 is 27. Now, a fast way to do it from here is this. What is 3 squared? 9. What is that term squared? Well, if you remember, they cancel out. Square and square root will cancel. You're left with the number underneath. 9 times 13 is 117. Good. We got to figure out, are these equal? Can anybody do that mentally? Are they equal? Yes. So does 117 equal 117? Yes. Is it a right triangle? Yes. It's a right triangle. So the hardest part on this one is simplifying this left side. If this left side simplifies to equal the right side, it comes out to be equals, then you do have a right triangle. Part B is easier. I wish they would have started with this one. Which one's the most important? 29. Why is it the most important? Because it's the longest, it's because it's the biggest. So that's your C term. So we have 29 squared. We don't know if it's equal to 24 squared plus 16 squared. All right, so when we simplify these, we get the following terms. We're going to add these together, and since it's 6 plus 6 on the ones digit, I know it's going to end in a 2. This should be 841, but this ends in a 2. So are they equal? No, these are not equal. All I have to know is that they're not equal. This is a no. I did that mentally because 6 plus 6 ends in a 2. It's not a 1. They're not a right triangle. That answers the question. So this number ends up being 832. In case you're wondering, this number is bigger than that. So remember, if it's like a crocodile mouth, it eats the bigger number. So what kind of triangle would that be? Well, that's an obtuse triangle because it's greater than. I know it doesn't ask you that, but that's a nice little extension. If you get this, you're solid for today's lesson. Example 2 is a topic that a lot of people mess up. So we're going to write some stuff so we can hopefully study this and remember it. The first question says, can these three numbers make a triangle? It doesn't say what type. It doesn't say, are they a right triangle? It doesn't say, is it acute or obtuse? It just says, can they even make a triangle? Well, here's the trick on this one, and you need to write this out to the side, please. So the key trick on can they make a triangle is you need to add the two smaller numbers. So write that note to yourself. Add two small numbers. All right, so we're going to do that first. We're going to add the two smaller numbers. What are the two small numbers? 2.8 plus 3.2. Are those two numbers, when they're added together, are they greater than 4.2? If they are greater than, then yes, they can make a triangle. If those two small ones are greater than the big number alone, then it can make a triangle. Think about this one real quick. If I give you the numbers 1, 2, 3, can these three numbers make a triangle? Well, what's the check? You add the two small numbers, okay, 1 plus 2, and they should be greater than that third number. Are they greater than 3? Not greater than. So this cannot make a triangle. It cannot make a triangle. This is just a side example. All right. So I want you to focus on those numbers again. So since it can make a triangle, we should be able to classify it. When you're classifying, you got to remember what famous formula? CAB, the Pythagorean Theorem. Out of these three numbers, what's the most important? The biggest is what? 4.2. So the 4.2 goes in for C. The other terms are 2.8 and 3.2. Go ahead and simplify those real quick. All right, so what do we get when we get 4.2 squared? 17.64. 2.8 squared? 7.84. And 3.2? Say it again. 10.24. So adding those real quick, what do you get? 18? 18.8? 18.08. And on the left side, you get 17.64. Now, which of these numbers is bigger? This one over here. So that means the mouth opens up to the bigger one. How do you read that symbol right there? That is a less than symbol, and less than means acute. They go hand in hand. Small, that means less than, acute. Good. Try out these checkpoints. See how you can do on these three problems. 4 problems. 3 problems. Just do these 3. All right, here we go on these checkpoints. First off, tell whether it is a right triangle. So you should have yes or no answers on all of these. If you don't have yes or no on 1 and 2, then you're a little behind. So first up, what's the most important piece on that one? It's the 2 square root of 10. That piece right there is your hypotenuse. and we kind of don't exactly call it hypotenuse, we'll just call it C. So that one's our C term. So 2 square root of 10, that whole group squared, and then we'll have our 5 squared and 4 squared. So remember, there's a little trick I taught you. You can write them both out times each other, or you can remember 2 squared is 4. Square root of 10 squared, those cancel. I'm left with the number underneath. That's 4 times 10. 25 plus 16. 25 plus 16 is 41. And that right there is 40. Does 40 equal 41? No. Do these make a triangle? Right triangle? No. They do not make a right triangle. Over here, longest side is that one. That's my C term. So 3 square root of 61. We got to square it. We then have 18 squared and 15 squared. I don't know 18 squared. What's that? 324. 15 squared is 225. Once again, 3 squared is 9. 61, square root of 61 squared, they cancel. I'm left with just 61. So 61 times 9 is 549. And over here, yep, 549. So since they equal each other, do we have a right triangle? Yes, we have a right triangle. So make sure you answer the question. It is a yes or no question. That's the work you show to get it. This one has 2 steps. Number 3 has 2 steps. The first question is right here. Can they make a triangle? Can they make a triangle at all? The second part is, what type of triangle? So we're going to create 2 different situations. First off, can the numbers make a triangle? You need to write this so you get this straight in your head. Some of you are just trying to do one of them for both situations and it doesn't work. The second one was, what type of triangle will it make? So first off, can they make a triangle? There was a trick. I said add the 2 smaller numbers. So that would be 6.1 plus 9.4. I'm not squaring these terms, but I want to see, do they add to be bigger than 11.3? And do they add to be bigger than 11.3? Yes. So can they make a triangle? Yes. Since that is a true statement, we can say yes. Now we got to figure out what type. When you're dealing with what type, you have to use CAB. You have to use CAB for this one, and if you don't, you won't get it right. Unfortunately, a lot of people think they can just say obtuse, and it's always going to work. They look back at this little trick and try to use that to tell what type, and that does not work. You've got to use CAB. So, C term is our biggest. That's 11.3 squared. We're going to be figuring out this inequality, or if it's equals. And then the other 2 terms are 6.1 squared and 9.4 squared. What's 11.3 squared? 127.69. We then have our 6.1 squared, 37.21, and then 9.4 squared, 88.36. Adding these up, what do we end up getting? 125.57, and then over here we have 127.69. Which one's bigger? The 127. When it's greater than, what kind of triangle do we have? Obtuse. I'll go ahead and tell you, it is pure luck that they both came out to be greater than symbols. It's not always going to happen, because this is just telling you a yes or a no. If it's greater than, it's a yes. If it's less than, it's a no. Sometimes this is going to be equal. Sometimes this is going to be greater than. Sometimes it's going to be less than. So be careful. These are different ways to answer these questions. Make sure you understand both steps. Down here, the big topic is, can you use these 3 numbers and make a right triangle? Which one's the most important? The biggest. So that's 130 squared. The other numbers are 50 and 120. Does anybody know 130 squared? Anybody type that in? 16900. 50 squared is 2500. And I don't know 120 squared. What's that one? 144? Yeah. 14400. I knew that one. Alright, adding these up. Hey, guess what? Does it work out? So can these make a right angle is what the question is saying. And you would be able to say, oh, one too many. So can these make a right triangle? Yes, I have one too many zeros. Is it 2 zeros or 3? Okay, so can they make a right triangle? Yes. Can it make a right angle? Yes. I just had a really good question asked. They said, if this cannot make a triangle, meaning if this was a no, would you do this part? No. If it can't make a triangle, you can't use our formula. That was a great question.